Hello, everyone. Hi, it's time now. Welcome to Spookfish's third webinar in the series. Today, we are, I hope you can hear me. Thumbs up? Yes? Good.
Yeah,
Welcome
we
to
can hear you.
Spookfish's third webinar in the series. Today, we are exploring the world of the unseen to see how invisible light can help us see and achieve more. To introduce ourselves, we are Spookfish, based out of India, the UK, and Anupriya, and the USA. And today, Uni, Piyush, and myself, Anupriya, will take you through the webinar from the three offices respectively. Just in case you were wondering what is this teaser image about, I'm sure everyone's still on a high with the Tokyo Olympics. Neeraj Chopra, who is the man in the image, won the first gold for India in the javelin throw event. It was a huge success because this was our first athletic gold at the Olympics history. Now, speaking of strategy, how is Neeraj maximizing the impact of his javelin throw? We can clearly see his joints and work out the joint angles, but how can we measure the effort? More about this later in terms of what technology can do to help with this. A burning question. So most of us were caught up with the news of this major fire event that happened in Colombo from Sri Lanka, where a large container ship carrying thousands of tons of material had caught fire due to the leaking nitric acid. The losses of what happened were immeasurable, and it will take decades for the ecosystem and the fishermen to recover from this terrible loss. In fact, fire on ships are actually very, very common. Just to give you an example, a fire occurs almost 1 in 60 days, and the losses and the catastrophe is major. The saddest part is that this could actually have been prevented with a simple inspection system. And this is what this talk is going to tell you about. Just to tell you a little bit, so the light is divided into the EM spectrum. Apart from the visible light that human beings can see, there are other spectrums that can be useful for quality control. We will go through all these spectrums throughout this webinar, go through the use cases, and tell you a little bit about what these spectrums and how they can be useful in your own processes. Just have an open mind and think about applications that could be relevant with the real world problems that you're seeing. Now, Spookfish specializes in all of these spectra, and there are little examples of what products can help with this. These are the applications that we have worked with, but the use cases are massive. A little bit of a brief about Spookfish. We help with quality control automation, and we're based in India, UK, and now the USA. We specialize in the research of computer vision and machine learning, and our machines do not only help with the visible spectrum, but we also see beyond the visible spectrum to help customers with certain quality control problems that are relevant. And these machines are aimed to be fast and reliable because they have to match up to the production processes and ensure that all of the algorithms that are sitting behind use the latest AI and ML technologies as well. A bit about the technology and the verticals that we help with. On the left, you will see a bunch of the technologies that we have developed and work on. What is highlighted in green is what you will be learning about through this webinar today. And because we are talking about all of the spectra, they are applicable to any part of the process manufacturing sector and also applicable to specific application use cases. Right, so I'm going to hand it over to Piyush, who's in the New York, and later you will speak to Uni, who will handle the Q&A. Thank you, everyone, and speak to you soon. Piyush, over to you.
All right. Thanks, Priya. Thanks so much for that. So again, welcome everyone. Really appreciate you guys taking the time out to attend our webinar. I hope I'm clear and you guys are able to hear me as well as see me. Still working from home. So again, for today, as Anu mentioned, right, we'll kind of like take a short memory lane, and recall things that we learned in our physics classes in high school, kind of thing. And then we'll kind of build on that and talk a little bit about how we've essentially applied the theoretical knowledge that we essentially received when we were actually in high school. So again, when we think about the electromagnetic spectrum, right? And again, what really had been focused on essentially during the early parts of high school, especially at least for me, was when you kind of think about the white light that falls on a prism, it basically refracts because of the differences in the wavelength and all of that, and then you basically have like a really nice rainbow on the other side, ranging from the red on the top to the violet at the bottom, kind of thing, right? So obviously, it was very interesting to be able to see these things, but then there is a lot more that actually happens on either sides of the spectrum as well, right? I mean, there's like a whole range of waves that are essentially on the other side above the red, as well as the violet light that we essentially see. Okay, and our focus is really going to be on those and kind of tie that back to the quality assurance aspect that we have been essentially focusing on, as a part of our journey as an organization. So again, kind of just expanding beyond the visible light. So you kind of have the low energy, high wavelength spectra to the high energy, low wavelength waves kind of thing. And then again, you see the entire spectrum in between as well, right? So you basically have the microwaves, the short, medium, long wave infrared, and then the near infrared kind of thing. And then you kind of go into the visible light, which is essentially what's perceptible to human eyes. And then beyond the violet light, you basically have the ultraviolet light, the X-rays, and then of course the gamma rays. I mean, gamma rays, of course, you don't want to be stuck in the middle of that. I mean, no one wants to get incinerated. Again, just kidding. But yeah, I mean, that's basically the entire spectrum that we are essentially talking about. And then again, we'll kind of talk about how each of these different waves basically have different utilities in some of the products that we have built out, and how they're essentially helping solve real world problems as well. Okay. So again, when you think about the microwaves, right, this is something that is actually fairly common, specifically in terms of just checking, doing body checks and all of those kind of things from a security perspective. Let's say if someone is concealing like a weapon, right, a gun or something like that, right? So microwaves are essentially able to penetrate through that, and they're able to identify, as you can see from the photograph over here, any sort of concealed weaponry. You're essentially able to see that. So these microwaves are essentially not only good just from heating your cold lasagna, but yeah, I mean, a lot of other applications are also applicable over here. And then on the other side, from a quality control perspective, we've also seen people use microwaves for structural integrity as well, right? So again, in this particular case, if you see, it's just some sort of a brick kind of thing, or like a concrete slab that has been put together, and the microwaves are essentially able to identify the cracks in those spaces as well, right? And this is really important given what we essentially saw in Florida, where there was a structural collapse of one of the largest luxury buildings over here, which resulted in hundreds of deaths in Florida. And again, you never think about something like that, something like that could essentially happen in a country like United States, where regulations are so robust and strong, and people take quality and security in such, and hold them in such high regards as well. But you know what, it did happen where people did not really follow the appropriate code, and these things were completely avoidable, kind of thing. All right. So this is again, one of the things that we have seen essentially on the microwave side. Then moving on to long wave infrared. So again, Anupriya essentially talked about that nitrogen leak that essentially happened. Again, it was a terrible disaster that ended up happening, where the nitric acid essentially leaked out and ended up destroying the whole ship. And the impact of that, the ecological impact of that, will be felt through for decades to come as well, right? Which again, is completely avoidable. So again, we have our product called Supervision, which uses the long wave infrared. And the way it kind of works is it's essentially able to identify, the differences between the temperatures within the entire the object that it's essentially monitoring as well, right? So in the ship kind of an example, you are essentially able to see that at the bottom, you have like a huge buildup of like high temperature kind of thing, and someone could have noticed that and then could have taken some sort of like a corrective action as well, right? Unfortunately, they did not have one of our systems, so that's the impact of something like that, right? Similar kind of thing can essentially be done on where you have like a coal power plant where they have like huge piles of coal lying around kind of thing. And again, a similar kind of thing could essentially happen at like a sawmill where they're processing like millions of tons of wood, and they have all these things lying around as raw materials, and you never know, because one of these things, if they get to an ignition point, it could essentially start a fire as well, right? Which is definitely not ideal. And something like this can be easily identified. Again, if you look at the picture, we are essentially able to see that the green and the blue areas are, like perfectly fine, not a problem at all. But there's like a little area which is like, super heated in red, identified as red. And you're essentially able to like, take corrective action, right? I mean, once you know that there's a problem that needs to be addressed, you can essentially go ahead and do something about that, right? So again, with the minimal application of like technology and some sort of like a product to essentially identify and take some corrective action or preventative measures, would have essentially been able to avoid these sort of like catastrophic accidents as well. So one of the other things that we have essentially seen where this could have been like really useful is in terms of derailment of trains and all, where a lot of the times the actual accidents happen because the axle bearings essentially just give away, right? And then those kind of things can essentially be identified using these long wave infrared waves to identify the stress at each of these levels and how we are essentially able to identify that. And again, if you look at the graph below, we are essentially able to see like what's the actual like stress points, and then being able to take corrective action accordingly, right? So if you know that the temperatures have gone beyond a certain reference point, then you can essentially take some corrective actions as well. Okay. So that's one application of the long wave infrared. And again, as I mentioned, Supervision is the product that we call it, is essentially able to kind of like use this wavelength and take it forward from there. Then moving forward, so those were kind of like more on like large scale kind of thing. When you kind of like think about the individual product kind of an approach where we are essentially looking at the food and beverage industry, what we really have an example over here is our Snipe product, which is essentially able to look at this packaging component, right? So again, if you look at the center picture, what you're really able to see is that you have like a good seal being identified based on the infrared signature, where you have like the top and the bottom and the center aligned, like really lit up really brightly to indicate that it has been sealed off properly. And then against this control mechanism, we are essentially able to identify if there is a heat signature that is kind of missing, right? And then all of it is again done through the long wave infrared, where we are essentially able to identify these gaps and then obviously take appropriate action by rejecting these products and throwing it away. Because the last thing that you want is sending out a product in the market which doesn't meet the quality control requirements, and essentially could reduce or have an impact, an adverse impact on the experience of the consumer as well. I mean, no one really wants that. I mean, that's just a reputational risk. That's basically just not something I would say it's not ethical to do either, right? If you can't take some appropriate action to essentially make sure that the product that you're sending out is of good quality, then every corrective action should be taken into account as well. Now at the bottom one, you're basically able to see a similar kind of thing where we essentially have on the left-hand side what a good seal would essentially look like, and the heat signature for that. And then on the right-hand side, when it doesn't meet like a quality control, a reference data point, what it would essentially look like when the seal actually hasn't happened properly. Okay. Then the next product that we have using the long wave infrared is Harlequin. And again, I mean, this became really popular during COVID. And again, I mean, we're still living through that, but a lot of our clients already have this product at this point of time. So again, this example that you're seeing is basically, been installed at Bangalore International Airport, where this product essentially, allows you to do a temperature check of everyone who's entering the airport, and it does that based on again the heat signature, and it's essentially accurate within 0.25 degrees Celsius. Okay, and again, the scan takes like less than 1 second to essentially identify that and then move it along, right? So people don't really have to spend a lot of time in front of this camera to essentially take like, yeah, it doesn't really take a lot of time either, and then you can essentially just move forward, which is very helpful when you're looking at something like an airport where you have like thousands of people basically getting through the doors every single day. All right, so moving on, again, we'll kind of like come back to the same example that Anupriya was talking about with Neeraj Chopra, and how do we essentially measure the impact of these sort of like superhuman actions that people are essentially able to take during these high performance activities and all. So again, our product has been used in terms of identifying the heat signature on the joints that are most impacted when you're performing these kind of like activities, right? So again, on the right-hand side, we basically have a cricketer. Again, for people from the United States who don't know what cricket is, it's very similar to baseball. It's just that it's a much slower game, to be honest. But yeah. So what you're really able to see is that the heat signature, again, starting from the left, where the impact on the joints is like very minimal, where the person is just getting ready to hit the ball, and then towards the right, as you keep moving along, the impact on the joints becomes much higher, and then that basically results in the heat signature becoming much more stronger, and that's basically happening at the time of impact at the ball as well. Okay. So we are again able to use this, and again, this is something that is being used in the sporting industry as well, where people want to be able to see how their athletes are performing, and what kind of like impact each of the actions that they're essentially having on their bodies as well, right? Because as an athlete who needs to perform at like a very high level consistently, you need to make sure that the body is not only able to take the wear and tear, but the stresses that come along with that as well. Right? So it's very important, again, from like a sports analytics and kinematics perspective, which is very useful for coaches and training centers and all of that. Okay. The next one, again, coming back to the quality assurance aspect that we have essentially seen. So again, our Snipe product is also able to use the medium wave infrared, specifically from like a sealing perspective, where what we are really able to see is that if there is a seal that is, has like a small cut, again, as small as like, 1 millimeter or less than that, we are essentially able to identify that. Again, what the product is really able to do is, create a reference point of what a good seal would essentially look like. And then based on that, it's able to identify any sort of like misalignments and all. So again, if you look at it from a naked eye, you wouldn't even see what the difference is, but the system is essentially able to identify that, hey, you know what, there's like a really bright heat signature that I'm seeing in like one specific area and not the rest of the area where I would have expected it. And then it's able to, reject it accordingly. Similarly, when you think about like a stick pack where you have like the product being sealed within your stick pack, if you do have like some powder in the seal region where it shouldn't have been there at all, then you're essentially able to see that as well. So again, it's very useful to be able to know these kind of things and then being able to take corrective action rather than sending out like bad product out in the market as well. So again, this is just an example of another example of the medium wave infrared that we have used in identifying and monitoring like complex packaging and seals for our customers. The next one is the short wave and the near infrared kind of thing. So this again has a lot of application in the food and agriculture as well as the pharmaceutical industry. Specifically, if you think about the food and agriculture, again, in our example, we are basically taking an apple. Right, and an apple, again, if you think about it, you really don't think about the moisture content, and you're not really trying to identify if like it is homogeneous or very consistent across the board. But then when you actually like put it through the spectrometer, you're essentially able to see that there are actually differences, right? I mean, the fruit is essentially juicier in certain parts, and it's not so juicier in other parts, kind of thing, right? So what we are really able to see in this example of the apple as well as the leaf, where the moisture content is higher as compared to some of the other parts. And again, the pixels basically help you identify those differences as well. Now, application of something like this in the pharmaceutical industry is essentially, using the spectral characteristics of the surface. We are essentially able to identify, whether the compound, whether the pills are actually homogeneous and, if they are actually meeting the appropriate blending criteria as well. Okay, which is very helpful again if you think about it from the perspective of maintaining the consistency and ensuring that the product is kind of the way it's supposed to be used as well. The next one is basically a combination of different things that we have essentially done, specifically on the measurement of the moisture contents. Again, when you think about each of these things, like paper, obviously, if you have high moisture content, it doesn't really work. You don't want damp paper going out at all kind of thing. So we have our Clarion product, which essentially is able to identify or help with the moisture content within paper or metal sheets and all of those kind of things. Then on the pharmaceutical side, we want to make sure that there is no adverse effect of high moisture content in the environment and all of that, and that's being identified through our Marlin product. And then again on wood chips and food and beverages, we basically have our Supervision product, which allows you to identify and showcase if there is any sort of, or indicate if there is any sort of moisture content in those kind of things as well. And again, the idea really is that any sort of high moisture content could significantly impact the performance and the quality of each of these products, right? I mean, you definitely don't want damp paper. You don't want your wood chips to be damp. Again, when you're especially using them in a variety of different ways, where it could potentially have a significant impact in the performance of each of these contents as well. All right. So until this point of time, we've kind of looked at the microwave and the infrared kind of thing. So we'll basically move on to the other side of the spectrum, and we'll see how we have essentially used the ultraviolet and the X-rays to be able to identify issues and quality issues on some of the other things as well. So again, one example is essentially the stainless steel surface, so which is again really critical. Again, if you look at it from the naked eyes, you definitely don't see any sort of issues. You're like, you know what, this looks perfectly clean. But as soon as you put it under UV light, you basically start seeing all these dust particles and all. And again, if you're thinking about using these sort of metal sheets and specific applications, any sort of impurity could have significant impact in terms of how the actual products operate and work as well, right? So the idea really is that we are using these UV spectrum to essentially identify and detect any sort of issues, something as simple as dust particles or oil spills or anything like that, and then being able to identify that and then indicate that as well as an issue, so that we are able to control those things. At the bottom, you basically have again a bottle with a clear liquid in it, but again if there is any sort of leak detection or a dye tracing that we essentially want to be able to do, then the ultraviolet light essentially helps us to kind of see that, right? And again, it seems it's all perfectly blended over here, but if you look at the actual the UV under UV light, you're essentially able to see that there's a very specific a pattern that emerges, and you're able to see what level of blending has actually happened as well. So it allows you to kind of track these kind of things, and again, as I said, take corrective action and use the appropriate information as well. And again, the same product, Supervision, which allows you to do these kind of things. Moving on to the far side of the spectrum, when you look at the X-rays, now this again has a huge value addition for our clients, specifically in the pharmaceutical industry, where they have all these tablets and all. You might have a tablet which is not really fully formed, or it could be compromised, or it might not be there in one of the slots at all, kind of thing, right? So we are essentially able to identify all of these issues using our Marlin product, and then being able to identify that and kind of indicate it and then put it in a rejection bin, so that something like this doesn't actually go out to your consumers, right? As I said, I mean, a product which is not meeting the stringent quality requirements obviously is not a good thing, right? And then again, this is also helping a lot of our pharmaceutical customers to make sure that nothing that goes out hasn't been tested from a very rigorous perspective. So using our product, that they are able to really sleep well and be assured that nothing is going out which hasn't been tested properly. Then on the vial and the bottles that we are essentially using for vaccines and all of those kind of things. Again, if you look at the left side, The vial basically looks, pretty innocuous. There's nothing, doesn't seem anything wrong from a visible light perspective. But as soon as you put it through X-rays, you basically see like a little bit of a, an issue where you have some sort of a foreign object which shouldn't have been there, kind of thing, right? And then again, just imagine if the vaccine that you're taking right now basically had any of these impurities, which could have like a significant adverse effect. I mean, you definitely don't want those kind of things to happen to your body, right? So just making sure that every vial that goes out has been tested properly, it becomes like such a critical aspect of the whole testing process as well. And then this is basically being done through our product called Opal, where we are essentially able to check all the vials. Again, we are able to look through the clear contents. We are able to go through penetrate through the glass of the vial as well, and then being able to have very significant impact in terms of just identifying various impurities and all of those kind of things. And then finally, this is basically the whole summary of how we are essentially using different waves across our various product lines, and how that basically translates into different sectors that we are essentially servicing, right from like safety and surveillance to pharma to food and beverage, automotive, healthcare, and all of that, right? And then this basically is continuing to expand, where we are essentially identifying new use cases every single day, where we are able to apply these technologies, apply these spectrum that is available in nature, and just because of the technological advances that we are seeing in machine learning, AI, and just the tools, the cameras that are available to us at this point of time, where we are able to do a lot more work on the quality assurance and taking preventative measures in terms of avoiding catastrophes that we just talked about earlier, right? So with that, I'll hand it over to Uni and John, who will essentially lead us through the Q&A session. Thanks, everyone.
Thanks, Piyush. Thanks for the presentation to everyone. And being a sportsman myself, I want to say congrats to India on the gold medal in the javelin. I know we've got a few Finnish people on the webinar today, and I'm sure they would want to raise their hand and say Finland have won 7 gold medals in the javelin since 1908. So puts it into perspective with a population of 5 million. And I know there's a few Swedes and Germans on the call, and their gold medals combined don't reach Finland either. So I thought I would get that out the way. In terms of Q&A, we want this to be interactive. So if you want to raise your hand, you can do that virtually at the bottom of the screen, and we can invite you and ask a question. But historically, we've found very much that if there's any questions from the audience, that the chat box in the bottom right is a good way of doing that, and hopefully we will get a few questions. I know historically myself, and I know a lot of the team have worked very much in the visible spectrum, which is what everyone on the call is used to seeing the world in. So it is lovely to see actually how many different applications we've been able to work on that are outside of the visible spectrum. So I know the thermal is something we've got a post on, and this is something we've been working on massively over the past probably 4 or 5 years now. I can see that there's already a question on there, but I think this is more specific to do with products in terms of technical details. So Devendra, we will do that. One of my colleagues, given you're based in India, one of my colleagues from the Indian office will be in touch with you. Thanks for the email. And if you haven't heard anything in the next 2 days, please reach out to me, and I will make sure that you get some information to you. I know it's been quite a high level conversation, and on purpose, we don't really want to go too into detail with the products. It's more of an overview. But I can see I thought I could see that Ezra's raised their hand. Ezra, do you want to come on a video and unmute yourself, or have I seen something? My tech is letting me down because I can't see you in the queue.
Hi, Uni.
Ezra.
Can you hear me okay?
Ezra, it's very quiet. Are you able to crank up the volume?
Hold on a sec. I haven't used this before, but let me try. Can you hear me now?
Yeah, that's better, Ezra.
Okay. No, I just had a question. I wanted to know a bit more about your the measuring of the water content. I thought that was quite interesting. I thought it was a supervision, but was the technology. But what exactly are you doing there, and what applications are there?
Sure. Supervision is probably one I will hand over to our technical director, Sudeep, who has joined Anu on the video call. But Sudeep, do you want to jump in? I think my question was on water content. My understanding is that we've been more looking at the defects or particles within the water. But Sudeep, maybe I could ask you just to give us a brief overview on supervision and what we've been doing with the liquid side of things.
Yeah, for sure. In terms of measuring moisture content, water itself has a certain characteristic which can be picked up in the reflections captured by an SWIR camera. So we go through the wavelength range within the SWIR subspectrum, and then there are certain wavelengths where water can be characterized. So basically, you look at a surface, and then based on that response, the strength of the response, you're able to estimate how much moisture content is in the object that you're looking at. That it falls under the SWIR range, as Piyush has mentioned. The applicability is quite varied. It's currently being used quite a lot in the paper manufacturing industry, where we're ensuring that all the raw materials that go into the pulp have just the right amount of moisture, because any slight variation in that would result in a very different kind of quality in the paper being manufactured. But of course, going forward, the food industry has huge applicability for this, and that's something we're looking forward to implement.
Yeah, and Ezra, I just wanted to add a point. So most of these technologies that we work with are online solutions, whereas there would be offline and destructive solutions to measure the quality, and there are proven methods in the lab. But these are industrial cameras that can help you see in all the different bandwidths, and to that, there are limitations, but also a lot of use cases, because this is completely 100% in online.
Okay, thank you.
Thank you.
Thanks.
Thanks for the question, Ezra. I can see Raghavendra from Alchem also asking for some information, so I'll get the same colleague to send that to you. One of the questions was about ultraviolet, and maybe, given I'm not an expert, Sudeep, maybe you can take that as well. Is there any effects from the UV on pharma products? I'm assuming this is more, people know X-ray can be quite harmful. What does UV mean? Are there anything that people should be aware of?
It completely depends on the formulation that is being examined under UV. There could be some formulations where UV light has an effect on the molecule, but this is usually very rare, because compared to something like an X-ray radiation, UVs have relatively much lower energy, even though they are slightly higher than visible light. And of course, you also find some formulations which are sensitive to visible light. So these same formulations will be impacted under UV as well. But I'd say that probably makes up about 1 or 2% of the formulations out there. So mostly not much of an impact.
And it's a good point. I mean, the material properties have to be studied beforehand to understand the exposure time of, allowing any wavelength to be exposed for that. So that's carried out as well, dependent on the product.
Thanks, Anu. Thanks, Sudeep. Ashara Mittal, I can see a question using the IR for the cap seal quality. Is there any adverse effect on product quality? I can answer that very quickly. No, the thermal imaging cameras just see the world differently to us. So we see in color, the thermal camera sees it in the long wave or medium wave spectrum. So there's no adverse effect on the product quality. I would almost argue it's only an improvement in product quality, because that's what the system is doing, ensuring no defective products go out to the market. Annoyingly, I don't know why my technology is letting me down. Oh no, perfect. Devendra, hand raised. If you don't mind unmuting yourself and coming on screen, we'd love to hear your question.
Actually, I have a query. Whether do you have any device to detect the temperatures of electrical installations, electrical fixtures, electrical joints, where we can check the temperature?
I'll let you take that.
Yeah, sorry. Yes, Mr. Devendra. So thermal cameras, infrared cameras are very frequently used for monitoring substations, because in electrical substations, if there are any joints which overheat, they tend to cause major disruptions over time. Substation monitoring is a very widely used application, and we can use either the medium wave or the long wave IR cameras to achieve this.
So these are portable devices which can be used at multiple locations, right?
Yes, yes. You get either portable device or fixed devices. For electrical substation monitoring, it'll definitely be a portable device.
Yeah, so there are a lot of studies that show that the preventive maintenance of electrical panels and the frequency of it as well helps you save a lot of downtime in production. I mean, we could send you these case studies just to show. So it's preferred that these are portable machines and cameras which will have the recording of the data and the data analysis to also help you track the time of the deviation in terms of when component can go wrong. So yeah.
Thanks, Sanu. Devendra, hopefully that answers your questions. And if you have any further, please come back to us, and we'd love to help you out with that. Yunus, I can see, I can send this straight to Anu and Sudeep, given you're on a roll there answering questions. Asking about X-ray or UV, whether they can use to detect packed blister products. So we're talking pharma lines, and there's actually two questions here. Filled and packed blisters pre-cutting, and then the same color blister with the same product or object, is that possible?
In short, yes. UV rays, no, but X-rays can look through aluminum foils. Many of the more secure products and moisture sensitive products are packed with aluminum on both sides in blister packing machines, in which case you can't see through the foil with a normal camera. We can definitely use X-rays to look through the foil to ensure that the content inside the blister is intact and present, because sometimes the tablets just jump out just before sealing. So it definitely helps. And same color blister and same product, yes, absolutely, because X-rays work on the material composition rather than the color or appearance, or visible appearance, I should say, of the product and the foil. And given they're working on the chemical composition, the product will definitely be of a different chemical composition to the foil. So yes, we can differentiate the two.
Brilliant. Thanks, Sudeep. I can see Jay Kumar's mentioned the handheld IR cameras as well. I think you already answered that earlier, Sudeep. Another one from Devendra. I think just asking for the thermal camera information. So again, I'll get one of my colleagues, Devendra, to come back to you directly on that. Jörg, question from Austria. Are you able to measure not water content, but water activity of coated tablets with one of your products? Sudeep, I will fire this over to you.
I have more questions to ask before I can answer.
Yeah, if you don't mind, could you unmute and tell us what does water activity in coated tablets mean?
or maybe the mic is not working. But then, yeah, it would be if the assumption of water activity.
Sorry, it's the free available water. So it's not the bounded water, but it's the free water of the tablet.
Okay, right. I think there should be a way to do it.
Yeah.
We need to work on it a little bit because this is more of an analysis where we need to take multiple images in varying conditions and then try to figure out what the free water content or the activity is. We will look into this a little more and get back to you. Not 100% clear just yet.
Plus, if we can validate giving different percentages of the water activity, that would also be useful learning for the machine learning engine.
Yeah. Okay, thank you.
Okay,
Thank you.
thanks.
Hey, Beauty, we also have a raised hand by Mr. K. Somu.
Somu, would you be able to unmute yourself and come on screen if possible to ask a question?
Hi team, this is Anil Chaudhary calling from from Alchem team. So
Hey, Anil.
Hi, I think this issue was already discussed with Anupriya madam. So we are looking for some vision system for our one of the sachet inserter machine of bulk packing line. Okay. So we have oxygen scavenger rolls running onto this system. Okay. So what happens is oxygen scavengers don't come with any eye mark or transparent holes. Okay. In traditional way, silica gels comes with this type of arrangement. So the sensors will detect this system and it will cut at exact point. Okay. But for this oxygen scavenger pouches, we don't have any cross check point. Okay. We traditionally doing on basis of measurement basis. Okay. For what is the maximum height of this pouches, we will cut at the servo drive. Okay. So we want some vision system that will check at what point it has to cut that pouches so that there won't be any miscut and spillage of that ferrous particle into my product.
Okay,
Yes.
okay, understood. Yeah, I think there are multiple ways we can achieve this. I mean, one thing that comes to mind, given that we've discussed the infrared spectrum quite in depth today, the content inside each of those packages will react differently to heat compared to the parts where there is no material inside. So if you can lightly heat up the element just by say 2 or 3 degrees, and then look at it with an IR camera, we should be able to differentiate parts where the material is present and where it's not. And based on that, you can verify the exact cutting point between different packs.
No, oxygen scavengers are very much reactive in nature, so we can't increase the temperature. Instead, we need to we need to have some certain arrangement. Only it has to check at certain point. Okay, there is no way we can expose this onto the air, or neither we can increase the temperature.
Okay. Great. I think we'll need to discuss this a little more in detail to figure out what could be used to differentiate between the material and non-material. So we'll take this off. I think we'll try and give you a call maybe tomorrow to discuss this more in depth.
Yeah, and one thing that helps us a lot in terms of understanding problems like this, we have a spectrum of Earth's camera that can help us switch between different spectrums. So that really helps because often the solution is not easily known until you actually apply it and see the signatures and understand it, because every material property is different. So we would try that as our assumption.
Sure.
Yeah.
Meanwhile, I'll share if anything required. Then, based on that, you just provide the suitable option.
Yeah, absolutely.
Sure, sir.
Thanks.
Thank you.
Thanks, Anil. And a question from Devendra is, do you have any systems for measuring the flow meters of water pipelines without contacting? Now, that actually is maybe catching me out a bit. Sudeep, Anu, do you want a bit more clarity on that question?
Yeah, again, I have a question to ask before I could answer, but my assumption is that there are very sophisticated sensors, but they are contact based to measure flow. To measure the flow, and could that be a solution rather than using an optical system? But
I think Devendra's raised his hand. So Devendra, feel free to unmute yourself and come on screen if you feel brave, and provide a bit of clarity and expand on the question. And I will say this is probably the last question. I know we like to keep these Q&A sessions short and sweet, so that people stay engaged. So Devendra, please come on.
Actually, I am looking for a system or a device by which water flow can be measured along with the totalizer, but without fabricating into the pipeline, so that it can be fixed from outside
okay,
without disturbing the
Okay.
pipeline.
okay.
Is the pipeline made of metal?
Yes, it is SS316L electropolished.
Okay. Looking through that.
Yeah, I mean, something we don't know the answer immediately, but we will research and let you know, Mr. Devendra.
Okay, fine, thank you.
Yeah, thanks.
Devendra, thank you for the question. I can see Eunice has asked a question, but Eunice, maybe we can come back to you on that offline. And I think I just want to say a big thank you from the Spookfish team to everyone who's made the time and effort to join this call today. Hopefully it's been of interest, and we hope you'll join us again in the future. We're trialing a 12 part series on webinars, one a month. So we'd love to see you on these again, but feel free to reach out to us at any time if you think that vision could help your efficiency on your production line or any application that you're working with. So thank you very much, everyone, and we will be sharing this webinar to everyone that has signed up to it. So thank you. Have a great evening, and all the best.